is CS50. This is the start of week 8, and you may recall that we left off last time looking at a new language altogether. In fact, one that's fairly lightweight, and it's not even a programming language. It's this markup language that lets us actually structure and make web pages. And we use something else in conjunction with this, or you soon will, if you haven't already. We're going to use cascading style sheets, or CSS, which is another type of language with properties and values that's going to let us do things like change the color and change the position and these kinds of tweaks. But today and onward, we start to focus on more powerful languages, actual programming languages like PHP. So PHP has been around for some time, and as you'll see, it was designed primarily early on for actual use in web development and actually generating web pages. So what kinds of features does a language need in order to make web pages dynamically with it? In other words, if you want to generate content dynamically, like Facebook's news feed, which changes constantly, or instant messages that pop up from time to time, like what's the key piece of functionality you need in a programming language that would let you dynamically print new information to the screen? Code, okay, won't take that. A little more precise. I mean, we could do this with C, frankly. It would be a pain in the neck, but is this commitment? Variables, okay, sure. Variables could certainly help us out, and even something simpler. We used it in the very first program of the very first day when we actually said hello world. Print, right? Print or printf in the world of C. So all this time, we've had at our disposal a language, C in particular, and even Scratch for that matter, that can generate strings of text. Well, if HTML, as we saw last week, is just a whole bunch of strings of text, albeit with open brackets and close brackets and some kind of rhyme and reason behind it, well, then we could really start generating web pages either manually by typing them out in gedit or in Microsoft Word for that matter. We just need a text editor. Or we could write code, to your suggestion earlier, that would let us dynamically generate HTML. And that's what we're going to start doing with PHP, and ultimately even with a language called JavaScript, is use one language to generate another. And indeed, this is what Facebook and many, many other sites do to actually dynamically display new information to you. So let's begin with this, a cryptic-looking line, but one that's actually pretty powerful. Thus far, we've been using C, which is a compiled language. And just a quick recap. A compiled language has what characteristic? You obviously need to compile it, but what does that mean? Yeah. Okay, it needs to be assembled into machine code. So you take your source code, which is sort of English-like, you convert that to something lower level, which is ultimately called object code, zeros and ones, and it's those zeros and ones that a CPU, like those made by Intel, actually understand. Now, PHP and Python and Ruby and JavaScript and bunches of other languages are not compiled languages, but interpreted languages, which means you just type them, and then you don't turn them into zeros and ones. You instead just provide them as input to someone else's program called an interpreter, and that person's program has been designed to understand what each and every symbol in Python or PHP or Ruby or any number of other languages means. And so all we need is something like this. So in fact, I'm going to go over to the appliance here, just into any old window, and I'm going to go ahead and open a file called, say, hello. Now, previously, I might have saved this even with a file extension, but I'm going to do something even simpler here. I'm going to go ahead and start this file with this cryptic syntax, so user bin n for environment, PHP. This is simply one line of code that's going to tell my operating system, go find in your local environment, whatever that is, wherever PHP is, the interpreter, and go ahead and use that interpreter to interpret the following code. Now, this is kind of an ugly feature of PHP, but in this language, anytime you write PHP code, you need to have one of these ugly PHP tags demarcating the beginning of your code, open bracket, question mark, PHP. But below here, I can now do something quite simple, like printf, hello, comma, world, backslash n, close quote, close parenthesis, and then just for good measure, I'm going to go ahead and close my PHP tag over here, so that everything looks nicely pretty printed. And as soon as I click save, gedit is actually smart enough to look at that very first line and realize, ooh, you're writing PHP code, let me syntax highlight it with the colors here so that it stands out a little more. But now I'm going to go down to my terminal window. I'll zoom in. This program was called hello, so I'm going to do /hello, but permission denied in bash. We actually heard of that thing a couple weeks ago in the context of shell shock, one of those bugs. But permission denied, we've seen before, maybe in a different context. Does anyone recall how you might fix something where permission is denied like this? What's the command, at least? Yeah, chmod, for changing the mode of a file. And you'll get all the more used to this next week with a subsequent problem set. But for now, I'm going to change the mode, not to be readable, but to give everyone executability privileges, the ability to run this file, and I'm going to assign that to the file hello. If I now do /hello, enter, you see, in fact, my program, hello world. And what skip did I clearly skip altogether? Compiling. So I just ran this program quite simply. And it turns out you can do this with a lot of syntax reminiscent of C. Let me go into today's code, which I've put into my vhost directory here for reasons we'll come back to. And I'm going to go into, let's say, conditions 1. And you'll see here, first and foremost, a whole bunch of comments. But this is actually a recreation in PHP of a program we did in like week 1 called conditions1.c, where the purpose and life of this program is apparently to ask the user for an integer and then do some fluffy analysis on it, whereby you say if it's positive or negative or equal to 0. And I bring this up only because, except for maybe one little detail, it's indistinguishable so far from C. What's the one characteristic here that maybe jumps out at you as a little different? Maybe two things, yeah. The $n? Yeah, so $n is present, and dollar signs, as we'll see, are going to be affixed to the beginning of any variable in PHP. It's both good and bad. Good in that it's sort of obvious what's a variable, bad in that it's yet another thing to type. And there's one other thing we haven't quite seen, at least by this spelling. Yeah. Read line. Read line we didn't see per se in C, even though there exists something similar, but we've used getString, and this is its counterpart. So if I go into this directory, which happens to be, as I'll explain in a bit, in my vhost directory and my source8 directory, and I go ahead and do /conditions1, you'll see, again, the same issue, permission denied. So let me zoom in and do chmod a plus x on conditions. /conditions. I'd like an integer, please, 50, and we could play this game all day long. It's going to behave exactly as it did in week 1. Okay, so not all that different, except not just that slight bit of syntax, but at the top, I again had this line, which allowed me to create something that looked like a C program called hello, called conditions1, but it's not zeros and ones I'm executing directly. It's instead running this interpreter whose name happens to be identical to the language. The program is called PHP, and my code below line 1 is being passed into it. We can do another fairly simple example, reminiscent of something we did weeks ago. Again, a sort of arbitrary chunk of code that apparently does what when you run it? What's this going to print, presumably? So initially on line 16, it's going to say x is now 2, probably. %d is the same as %i for printf. So then it's cubing, ... in line 17. And then line 18 appears to call a function called cube. And where is cube defined? Well, it looks like in line 25. So that's not all that different. I've got some comments above it. But for the most part, it's a fairly straightforward porting or conversion from the C program to the PHP version. But there are now a couple of differences that maybe should jump out. What else is different about how you might write the same program in C? There's no prototype up top. So PHP, and frankly, a lot of modern languages, are a lot smarter and more helpful than C compilers in that you can put the function up here, you can put a function down here, and the interpreter is going to do you the favor of reading the whole file before it decides that some function doesn't exist. So a nice improvement years later. But there's also something else different or absent here. Yeah? We don't have to declare the types of variables, so we'll see before long that there are different types in PHP, but you don't need to specify them, which also is both good and bad. And there's one other thing missing. There's no libraries. Okay, so that's nice. We get a lot more out of the box. So there's actually a lot more things than I thought were different. How about way hand back? What's that? Say once more. No pointers. Okay, at least in this example, no, that's fair. So there are not pointers in PHP actually in general. There are something called references, but we won't spend too much time there. And what else? Main. So this was the biggie I was thinking of. Notice there's no main entry point. You simply start writing your code. And this is actually going to be advantageous when we transition momentarily to actually using the same language For web-based programming, for which we don't want to have just one entry point, we might want to have a bunch of URLs, a bunch of different files, all taking in user input and producing output. But here is the very disheartening example that I promised last time, namely in this folder here, misspellings. So in this file speller, which we won't spend too much time on, there is essentially a porting. P-O-R-T is just the word given when you say you convert from one language to another, manually usually. This is a porting of the C version of speller from PSET5, and I essentially try to convert it line by line as closely as I can. So if you like this kind of thing, it actually is worth at some point pulling them both up side by side and see what's the same and what's different. But they're pretty darn similar. If you remember what speller even looked like, even though you didn't have to change this file, it's pretty similar structurally, with just a couple changes here and there. So this is only to say that it's pretty straightforward to convert speller from C to PHP. But in dictionary, there's something even more compelling. Let me go ahead and create my own dictionary.php file. So slightly different in that we'll call it .php instead of .c. Because this is a PHP file, I do, slightly annoyingly, have to start the file with a PHP tag like that. And now I'm going to go ahead and define a few functions. Function called check, which is going to take in a word like before, but this argument's going to have a $sign because we're, again, using PHP. Another function from dictionary.c was load, and it took in the name of a dictionary, so I'll get that function ready to go. Another one in dictionary.c was what? Size was one of the nicest ones, at least if you kept some variable around. So size just has to return a variable. And then there was unload. So there were these 4 functions in problem set 5 that you needed to implement with some data structure or structures. So I promised that in PHP, we can declare a hash table, for instance, all that more easily. In fact, if I want a hash table, I'm just going to go like that. And there's my hash table. And that's the note, disheartening, that we left off on last time. And you know what? If I want a variable for size, well, this one's not all that different from C, but I'm going to go ahead and do that. And notice no data type. And I'll go back later and actually add some comments here. But what about load? If $dictionary is the name of my file, and I actually want to load words into this table now, I can actually do something fairly simple. One, and this is minorly annoying, in PHP you have to specify inside of a function if you want to access some global variable that's defined outside, but that's not particularly interesting right now. What's more interesting is this for each construct that I mentioned last time, and it turns out that PHP has a function called file, whose purpose in life is to open a file and read in all of its lines into an array and hand them back to you, which is to say I can do dictionary, so that now effectively when I call file, this is going to hand me back an array of words from the file. It's not all that good. It's still going to be a line of words, something linear, but I can go ahead and iterate over each of these words using that syntax we saw briefly last time, and you'll see it more in the upcoming PSET. But now I have a loop iterating over each word in the dictionary, and on each iteration, recall I'm calling the current word word, and all it's going to take to put a word into the dictionary is going to be word gets true. That's my insert function. That's my load function for my dictionary. Now, it's a bit of a cheat because, you know what, there's actually \n's at the end of the words that I should probably get rid of, but that's not a problem because PHP has a function called chop, which literally chops off one character at the very end, so no problem there. We've gone ahead and actually shortened that to just this. And now I should probably keep track of size, so let's at least do this, size ++. I can do that as before. And then this is probably going to work just fine, so let's return true. Done. PSET 5. Okay, we're going to do that again with the next PSET too. So what about size? Well, this one hopefully is about as you would expect last time, although I have to do this stupid global thing. It's just an artifact from the language's design. But check is a little more interesting. So if I'm passed in $word, I first want to have access to that global variable table. And now if I want to check if a word is there, I can simply say, if it is true that the following is set in the table, then go ahead and return true, else return false. Done. The other half of PSET 5. All right, so again, I'm cutting a few corners in fairness. I should probably spend a few more seconds on this implementation. and I probably shouldn't mock all the hours you put on the pset so much. So stir to lower is a function. Something similar exists in C, at least for characters, but PHP's got a whole string version. That's going to force everything to lowercase, which some of you might have done to canonicalize what you were putting in your dictionary. And now you can do this in C too. This has nothing to do with PHP, but anytime you have a Boolean condition, like something on line 10 there, which is only going to evaluate to true or false, and your if-else is clearly returning true or false, I could simply really make this sexier and just do something like this, so that there's my check function. Right? If the Boolean returns a true or a false, let's just return it straight away. And there's a few other tweaks I could make here and there. Unload, by the way, that's done. Nothing to do there. Since all of the memory in PHP and many other languages is actually managed for you. So whereas in C, as you've learned painfully, anything you malloc or calloc or realloc, you have to free yourself. Anything you fopen, you have to fclose, so that resources are ultimately freed, and tools like Valgrind don't notice and don't complain, which is a good thing to run on them. But surely there must be some catch, right? Otherwise, we kind of wasted a whole bunch of weeks. So there's any number of reasons why we sort of take this trajectory, but there is a trade-off, right? This has been thematic. So what might a trade-off be here? Moving from C to PHP. Feels like all wins so far, other than a bit of ugliness here or there. Yeah. What's that? Speed. Okay, well, my speed was pretty fast, right? But speed of execution of the program? Okay, so that's a fair point. So as it would happen, I, in advance, queued up both my try solution. The one I had on the big board was a try-based solution, and I have that in this directory here. So in a moment, I can go ahead and run this on the King James Bible, hitting enter. And this is hopefully a correct implementation. At the end, gives me time in total of 0.38 seconds for that one somewhat arbitrary example. And if I now go into the second terminal window here, where I first opened gedit, let me go into today's code, which again is in this directory here. And let me go ahead and run speller. So just to be clear, this is the PHP version. I'm just showing the top of it here. So if I do speller of tilde CS50, PHP texts, King James, enter. Okay, it's still faster than writing it in C. But the total time is, notice, 0.93, whereas my C-based implementation was 0.38. So it's a non-trivial difference, and this is just on one file. If you were to run the two programs versus the big board and have a whole bunch of inputs tested, this would surely add up, and if we had even larger data sets, this too would add up all the more. So yes, paying some price of speed is indeed the case. What else? Yeah. Amount of RAM used. So I didn't give one second thought when writing this PHP version as to how much memory I was using. I'm completely deferring that to PHP itself and whoever wrote that program. And that might be okay, but if I actually really care about squeezing as much performance out of my program or out of my website or out of whatever tool I'm building, maybe PHP indeed is not the right language. And in fact, that is why, for instance, many web servers, the actual programs that serve up web content, are not written in PHP or in Python or Ruby. They are written, like you'll now do with pset6, in C, so that you can squeeze every bit of performance out of it and really exercise fine-grained control over what's going on underneath the hood and not just take for granted some higher-level data structure. Consider, after all, whoever in PHP implemented that notion of a hash table. It's actually more properly called an associative array. Does he or she have any idea what kind of inputs you are going to be putting into the structure? So obviously not, right? It's a generic tool in the toolkit that's provided to anyone who wants to use it, and so surely it can't be optimized ultimately for exactly what you want to do. So trade-offs. Development time might differ, performance might differ, complexity or memory usage might differ, and so what you'll find increasingly is that there's going to be different tools for the trade, and in fact, for a super majority of people's final projects in this class, believe it or not, C is not going to be the right language to use. And in fact, one of the takeaways ultimately for any class like this is to get you thinking about, well, what should you pull off the shelf when you want to solve some problem? And indeed, we'll cross this bridge even more as we look at more languages even beyond today. So let's transition now to perhaps a more familiar context for using a language like PHP. It's somewhat common to use at the command line, writing scripts like I did, but it's much, much more common, and it was intended to be used in the form of files that typically end in .php, but that's not a prerequisite, that themselves generate web content. So let me go ahead and open a few examples I prepared in advance, and these are actually sort of true stories, in that one of the first things I ever did myself after finishing CS50, and maybe I think CS51 years ago, is my roommate and I were helping to run the freshman intramural sports program, which at the time had freshmen registering for various sports by filling out a piece of paper, as it was called, walking across the yard to Wigglesworth and dropping it in some proctor's door drop. And then he or she would go through them and then actually email us manually that we're registered for some sport. So clearly an opportunity for improvement. These days you might turn to just Google Forms, but back in the day we had actually reached for, this wasn't even that long ago, reached for a programming language that wasn't PHP at the time. It was something called Perl, which has gone out of vogue since, but the idea is the same. And I essentially sat down to try to port those Perl versions to PHP, but in full disclaimer, did not give any thought to the aesthetics just yet. So here is a web page. This is a file. If I zoom in, it's apparently called froshim0.php, just because it's our first examples in this series. And notice that it has what appears to be a very ugly HTML form, but a form is interesting because it allows me to provide user input to the browser. Now, last time when we had a form, to whom did we submit our query parameter, the Q parameter it was called? So to Google, right? We totally punted on the idea of doing anything with that input, but today we start producing output. And the behavior I'm going to see here initially is pretty trivial. David, I'll check off gender here, say Matthews here. I won't be captain. I'm going to click register, and notice that the URL has changed to register-0.php, and then there's this ugly text here. I gave no thought to the formatting of this, but what is interesting is that 3 values were apparently passed in. This is PHP's sort of equivalent to printf. We'll see what it's really called in a bit, that just prints out what you passed into it. So this suggests that that form had at least 3 fields to it. And you saw me type them in. One was my name, one was gender, one was dormitory, and captain didn't even get sent to the server because I didn't check it. So this is to say, apparently, when you submit things on the web, not only does the URL sometimes change, sometimes it doesn't. In fact, the file name changed, but what is absent from the URL that we did see last time with Google? Yeah. There's no query string. There's no question mark something. There's no question mark Q equals cats, as we did last time. And there's certainly no question mark name equals David or dorm equals Matthews. So where is that all going? Well, let me go back to gedit here and open up the first of those files in my vhost localhost public directory here and go into froshim0. So it turns out that almost all of this page is just HTML. And this might be unfamiliar to you, but it soon will be more so with pset 6 and pset 7 and pset 8. But this is just an HTML page, and the interesting stuff seems to be over here. A form tag whose action attribute has a value of register 0. That's why when I submit this, it goes to that file. But method is different today, post. So it turns out there's at least 2 methods on the web used to send information from browser to server. Get puts it in the URL, post puts it elsewhere. And when and why might you actually want a website to use post then instead of get, just intuitively? Any website. What kind of data should be passed just by inference now via post as opposed to get, if we've seen the two differences? If you want something to be secure, so you might type a password into a website, a credit card into a website, would kind of be suboptimal if the browser put that value inside of the URL. Why? Well, you see it, which doesn't seem to be such a big deal, but odds are you pretty frequently walk away from your computer, or you use computer labs, and so someone else, or even a roommate, could easily walk up and see that private information. When you send an email via the web, you probably don't want that data ending up in the URL as well, and so there's any number of reasons why we might want to put it here. And photos, right? I can't even quite imagine how you would take a graphic, like a JPEG, and put it into a URL. You could do it. There's ways of encoding it, but it's just not straightforward like that. So register 0 is actually very underwhelming. All it says literally is this. It prints out, inside of some HTML tags, the following. I've got a PHP tag here nested inside of a pre tag. Pre just means pre-formatted text, monospaced, like a typewriter. Print R is a print recursive function. And then there's this interesting thing here, and we'll come back to this because there's others, but $_post appears to be a variable in PHP in which anything you send from browser to server gets stored for you. And we'll see how to get at that information before long. But first, let's go back to a slightly different example, going into register, or rather frosh.iams1.php, which looks a little different. I took a little more effort at the formatting, even though it's still pretty ugly. But I'm going to go ahead and type in David now, male. We'll check captain this time. We'll do Matthews and register. And this time it says, not really. All right, so what's register 1? Let me go into open register 1. And all right, so this is interesting. And this is a stepping stone now toward more interesting programs. Notice the top of this file has a PHP tag, as well as some comments. And these are, for now, a distraction. So let's just get rid of those comments, just like they're in C. And I claim with this chunk of code with a comment that this code is validating the submission. Well, it turns out that variables like $_post are called super globals. They're like these special global variables that are just omnipresently available within your program. And you can use square bracket notation to index into them, not using numbers like 0, 1, 2, 3, but actual words. So you can think of $_post as sort of a hash table that you can pass a key into, a lookup word, in between the square brackets, and it's going to give you back the value that the user actually provided. PHP has a function called empty that just says yes or no, this variable is empty or not. We have these double bars, which just means or, like in C. So in effect, this line 4 is just saying if the user didn't give a name, or didn't give a gender, or didn't give a dorm, go ahead and redirect him or her via this line here. So this is a little cryptic, but this just means literally go back to this location, so it punts the user back to wherever he or she came from. But it's a little inelegant in that I hard-coded it. But what if this if condition does not evaluate to true? What if the user did give me his or her name and dorm and gender? That if condition's not going to evaluate to true, so I don't hit the exit in line 7. So what happens? And this is what's interesting about PHP. You can drop into and out of PHP mode, so to speak. If you want some code to execute, you can open and close a PHP tag and put code there like I've done here. As soon as you close the PHP tag, the server is just going to spit out whatever you put there. And indeed, this was part of the original design of PHP, for better or for worse, was this commingling of code and markup language. And we'll see that this very quickly devolves into a mess, and so we'll do better than this ultimately, but just notice the ease with which I'm actually able to execute some logic. But still a bit underwhelming. Let's open up version 2 of frosh.iams, which apparently submits to register2.php. So this file is actually going to look almost the same. I'm going to go to frosh.iams2. But in frosh.iams2, let's see what happens. David, click the radio button as it's called, Matthews, no captain, register. You are registered, not really. Oh, wait, we just did that example, didn't we? All right. Stand by. We'll do the 3. Oh, clearly something's about to happen with Gmail, so we'll get there. So frosh.iams3 looks like this. No different, but when I do David, male, Matthews, and register, this third and final version claims, quite simply, you are registered really. That's sort of immaterial. But I claim with this third and final version, I have now recreated exactly what my roommate and I built for the frosh.iams program years ago. And it was simple. There was no database, no Excel spreadsheet, but more importantly, there was no more paper, because what we did with this program was to actually email the proctor, who was previously receiving these things via forms, and apparently we've programmed this in such a way that when someone registers, John Harvard's account emails the proctor, or himself in this case, John Harvard, with the following text. This person just registered. Name is David, captain is blank, gender male, and dorm Matthews. So what happened there? Well, the file in question here is apparently register3.php, and if I open this, you'll see both the power of code like this and also, frankly, the insecurity of a system like email. I have just effectively pretended to be John Harvard in the following way. I have the open PHP tag up top, which just says, here comes some PHP code. Down here, turns out there are libraries in PHP. You just don't need to include header files as much. You get more with the kitchen sink, so to speak. But this time, in line 4, I do want a special library called PHP Mailer, which is something you can install for free in many systems. Down here, I'm validating the submission just by checking, did the user give me a name, a gender, and a dorm? And if so, go ahead and instantiate a mailer. You can think of this as being a line of code that just allocates. It's like malloc, but it's a little sexier in that you mention not just malloc and some generic number. You say, give me one of these. Give me a new one of these. And if you've programmed in Java or C++ or other languages, you might have seen this. But the short of it, if unfamiliar, this line puts into $mail a special struct called an object that has built-in email functionality. And in fact, notice some similar syntax. This is not a pointer per se. PHP just uses the same syntax. This line is saying, use SMTP, Simple Mail Transfer Protocol, which is just the protocol used to send mail. This is specifying use Harvard's SMTP server, which is somewhere here on campus. This is saying what TCP port number to talk to, and I just figured that out by Googling or asking the help desk. And then, so because Harvard uses some security on the mail server, at least to encrypt traffic between you and it, even though anyone can send to it, I'm going to turn on the TLS protocol for keeping this secure. But this is where things get a little scary. I can just arbitrarily say that I am J Harvard, and I can just arbitrarily email myself here, and then I can specify a subject with this line here, and this just looks ugly, but it's just a bunch of concatenation. Turns out PHP has a super useful symbol, like some languages, the dot operator, which just literally concatenates string after string after string, and you don't have to malloc or figure out the total length of the string, you just do it. And indeed, because I'm concatenating in all of these things with these dots, that's why the email I sent looked as it did. And then lastly here, I'm sending mail. So if this is false, I'm just going to die, which is a function that just prints to the screen some error message. But it is, in fact, calling the send function. Otherwise, if all of this fails, it redirects me back here. And why did I see that I'm registered really? Well, it happened right here. So I bring this up for a couple of reasons. One, this is exactly how, if you build some website for a final project or for the real world, this is how you send email reminders to your customers or your subscribers. This is how you send password reminders. This is how you send people messages that they have a new Facebook message pending or something like that. But it also speaks to the fact that this could have been very well from Davin or anyone else. And I say this kind of with a smile because I am quite sure what's going through several of your minds at this point. But this is one of those do as I say, not as I do kind of things, because it is trivial to forge emails like this. But as you may have seen or read in the Crimson of Late, it's also pretty trivial for people to trace them back to some origin. And ask me sometime, perhaps at CS50 lunch, how I first got acquainted very closely almost to the ad board many years ago, when I discovered how the internet worked. So in any case, slightly after the ad board did. So in any case, there's a whole bunch of super globals, as they're called here, one of which we saw, $_post. There's a counterpart called get, which is where stuff from a URL ends up going. And there's a whole bunch of others too, session and server and cookie. We'll come back to cookie some other time, but session is kind of cool because right now, up until now, everything we've done with a web browser is sort of stateless, so to speak. I can click around, access files on the server, something happens on the screen, but then the connection closes. The Internet Explorer or the Firefox icon stops spinning, and you just see what that web page contained. So HTTP is stateless in that once it makes a connection, gets some data, that's it. No more connection. Unlike Skype, unlike FaceTime, unlike GChat, which maintains a constant connection to the server, the web is fundamentally disconnected. Though we'll see before long how we can simulate things like Facebook chat and GChat, which maintain the illusion of or actually do maintain a constant connection using more modern technology. But if I go to, say, counter.php, this is another simple example, as we'll see, that currently thinks I've visited the site 0 times. But if I simply reload the page, it somehow knows I was here before. If I reload again, it knows I was here before, and again, and again, and again, and again. So there's some plussing going on. But notice the little thing spins ever so briefly up top and then disconnects. So it's not like I have a constant connection to my appliance. Well, if I go into counter.php, notice how simple it is. I first call this special function that we'll soon start taking for granted called session start. Start a session. And a session, henceforth, is just going to be a bucket, like a shopping cart in which you can put values and kind of trust as a programmer that they're going to be here when that user comes back. A second later, an hour later, even a year later, so long as he or she doesn't clear their cookies, as we'll eventually see. And now I just have an if condition here. So if the following key, called counter, is set inside of this superglobal, this hash table, if you will, called session. Then go ahead and grab the value from the session, think of this as a shopping cart, and store in a temporary variable called counter. Otherwise, if that value counter was not set in the so-called shopping cart, just initialize it to 0. Lastly, down here, go and put back into the shopping cart, or the session, the value of counter plus 1. So it turns out that this special container here, which again is one of these associative arrays, an array that you can index into using words instead of numbers, persists even after the user goes away. Again, I'll go back to the page now. It's been a minute or so, but it remembers that I've been here 19 times before. This is my 20th visit. And so this is going to be key to implementing any website that remembers that you're logged in, that you've put something literal in your shopping cart to buy, or that you have some number of messages pending. Anytime you want to remember information, we'll see that PHP, like several other languages, provides us with this illusion of state, even though, as you'll see in pset6, as you're making HTTP requests from client to server, that's it. Once you get back the response, there's nothing more coming back from the server by default. But we'll see how to work around that. Well, now, let's try to clean this up a little bit. We've seen a few different examples there. Oh, and as an aside, for those familiar or unfamiliar, the reason that the Frosh IMs example went from looking really ugly to slightly, well, still ugly, to slightly less ugly, though still ugly, is because if we look at the source code here, it turns out that I have this at the very top of the file. Turns out that Bootstrap is one of many freely available libraries out there that exist not for programming languages always, but for CSS or for JavaScript or HTML or any number of languages. And these folks here originally came out of Twitter, just have a whole bunch of styles. It's a massive file here that someone wrote, or someone's wrote over time, that specifies colors and formatting and whatnot, so that I can kind of borrow their syntax and not have to figure out how to lay out my form. This is also minified so that a computer can understand it, but not necessarily a human. So that's just why the stylization there changed. But let's now do better in terms of design, because if we stay down this road too long, our code's going to get messy and messier. So let's focus on these examples here, the last for today. So here is a super simple version 1.0 of CS50's website. It only has links to lectures and syllabus, and it's using that unordered list tag, the UL tag that we used last time. And if in fact, if I open up view page source, you'll see that this is really, really simple HTML. And in fact, even though this is a PHP file underneath the hood, it's still just spitting out only HTML for now. So if I click on lectures, we see this happens, and if I click on week 0, we see this, and if I click on Wednesday, we see this, and this apparently was the PDF of the slides from that day. All I've done is link with an anchor tag to this URL here. So this is only to say, this is a pretty simple version of CS50's website. Let's see how it's implemented. If I go into the MVC 0 directory, we'll see a few files. One is a README, so that if some of this is too fast, you can just poke around more leisurely later. And notice in here is an index.php file. It turns out that if you yourself, the human, don't specify a file name in a URL, the web server usually infers some default name for you. And index.something is generally the default. So that's why a moment ago when I visited this URL here, no file name, no file extension, no period in the URL, it just knew somehow magically to look for index.php. It's just a convention. Could be called anything. So if I now go into index.php, you'll see that, indeed, let's get rid of the comment here, because there's really nothing interesting to it. This is just hard-coded HTML. So that's consistent, though, with my claim that you can commingle HTML and PHP. There's no actual programming logic in here. And the other files are pretty much just as uninteresting. It's just hard-coded week 1 here to week 1M and week 1W for Monday and Wednesday. And then if I open up week 0, notice it's almost identical. And that's kind of a key takeaway. Notice just how redundant this is. These files barely change, and yet I pulled one of these copy-paste jobs where I took one file, presumably in week 0, copied it when week 1 came around, and tweaked a few values. We should probably be able to do better than this. So let's go back up to MVC and go into version 1, and notice I've got a few files, because what was common to all of those files just a moment ago? If I go back to version 0, let's go back into index and just postulate, once I get rid of the comments, what part of this page is presumably in every one of my files? Just call it out. Which lines are duplicated probably across all of these pages? Yeah. 1 through 9. Yeah, absolutely. 1 through 9, except maybe 8 changes a little bit because CS50 becomes lectures or week 0 or something, but almost identical. So all of this stuff is just kind of copied and pasted, and there's a couple other lines I can think of that are probably identical across all the files. Yeah, 12, sure, 12, 13, and 14 probably, just because the interesting stuff is happening on lines 11 and 10. So it would seem. So let's look at version 1, which tries to improve on this. In version 1 of this MVC example, we'll explain what MVC means in a moment, if I go into index, it kind of looks a little confusing now. It's not quite as simple as before, but once you start to read it carefully, it's pretty straightforward what it's doing. Apparently line 1 and line 8 have replaced all of the stuff you just identified, though just for good measure, I left the ULs there, just in case some days didn't have a list of things. And so require is kind of like pound include in C. It copies and pastes the contents effectively right here into this file. So in header.php, as you might infer from its name, is going to be the header of the page. It's kind of orphaned here. It only has the top to it, but there's no more content below. And if I look at footer, meanwhile, which was the other file mentioned, this one's even less interesting, but again, it's common to everything. So this is the footer, this is the header, this is the file that's changing, so why not try to factor out that commonality with these two lines here? But we can clean this up a little further. I'm going to go ahead and open up version 2, where we'll see that there's a new file, helpers.php. We'll see what that is in a moment. Let's go to index as the entry point as before. And now notice I'm requiring helpers.php, not header or footer, but helpers.php is kind of like helpers.c and helpers.h from pset 2 or pset 3 long ago when you actually did search and find for that pset and you had all of your code for sorting and searching in a separate file. That's what's going on here. And now line 3 looks a little different, and it's just one line. To make this even more clear, I could just do this to be stylistically consistent with everything else we've done, but that's not really changing the functionality. It's just one line of real code. Apparently, there's a function somewhere called render header, and this is where things get pretty powerful. Notice that inside of its parentheses is what other piece of syntax? It's probably a little hard to see, but notice I'll put some white space. There's square brackets. And square brackets we saw a bit ago in the context of associative arrays, which are, again, like hash tables. And if you think now to C, the order of arguments into a function has to always be the same. You have to remember what the order is, x, y, z, or z, y, x, and you have to always provide them in the same order or look them up if you've forgotten. But this seems to be a clever way of passing an arbitrary key value pairs, whereby title is the name of an argument in this case, and CS50 is its value. And the fact that I have these square brackets here means that I could also pass in something like week is 1, or 0, or 2, or 3. So we've parameterized this function in such a way that it can take multiple inputs, but for now it's just the one. If I now go into helpers.php, notice what it's doing. This is a little bit of new functionality, but for now just take on faith that this is the syntax with which you define a function in PHP. You literally say function. You don't specify a return type, and that's consistent with the variable detail earlier where you don't really strongly type. This just specifies that by default this takes an associative array as an argument, and you know what? If the user doesn't pass one in, assume a default value. This is a feature that C doesn't have for us, which is nice because now data, even if you don't give it anything, is going to be an array, but an empty one. And as an aside, extract just does something funky where it takes all of the keys from this associative array, all of the things you could put in square brackets, and creates variables out of them so that we can ultimately have access to them in footer.php and header.php. That's a little abstract, so let me point this out. In index.php, notice that I'm passing in a key value pair of title with a value of CS50. If I now look at helpers.php, notice that render header is extracting that data that I'm passing in and then requiring header.php. What I've done is sort of a poor man's implementation now of the following. If I open up header.php, notice that I've no longer hard-coded the word CS50 in this header file. I've put this admittedly atrociously named function, HTML special chars, in there. But notice what I've done. I've got open HTML. I then have open head and open title. And then inside of the title's open and close tags, I have a bit of PHP code. And this is a nice bit of syntax, which just means echo out. It literally means this. Echo the following, but this is sexier to write. Echo out the title that's been passed in. But what do you think HTML special chars is all about, especially if you have some prior HTML experience? What characters might be dangerous to pass into a web page where you're dynamically generating the web page with code like this? Let me go to this file, version 2, and see if I can't induce this. Version 2 is this, and notice everything is fine, working well. But suppose I go into index.php, and I specify that the title of my page is not CS50, it is open bracket script, alert, hello world, close single quote, close parenthesis, semicolon, open bracket slash script. Script, as we'll eventually see, is a tag that you can use to use another programming language called JavaScript inside of a web page. And now notice the logic here. Here is a key called title. Here is its crazy long value now. But if I go to the helpers page, or rather the header page, I'm calling this function on that title first. So if I now reload this page, I see this, which looks ridiculous, but it's safe. It just looks stupid. But suppose instead I had forgotten this. And mark my words, a non-zero number of you will forget to do this, and you'll get some industrious student or friend coming up to you at the CS50 fair or anonymously at night poking around on your website and essentially injecting code unbeknownst to you into your site somehow, because if I simply spit out title here and title there, well, if title literally looks like this, and PHP as a language that can spit out other languages' text, this is literally going to replace this tag with, of course, what I put elsewhere. So if I now go here and reload after undoing those safety mechanisms, now I have hello world here. Now, that's not all that big of a deal, but you could do something a little more malicious here, like there's other tags, as we'll see once we spend more time in JavaScript, like location.href gets quote-unquote HTTP, like business.com, but the opposite of that from the other day. And now you can induce a web page to actually go immediately to this web page here. And actually, I don't want to even go to business.com because I don't want to know what that is. But this too will trigger code to be injected into this page. So this is only to say that even though we're introducing super early on some of these more complex structures, it's all toward an end of making sure that your code is not exploitable. So now a third version here. It's getting a little fancier. I didn't really like the anal side of me was getting a little annoyed by the fact that I had a function called render header and render footer that were almost identical. So it occurred to me, why don't I parameterize these functions into just one called render, have it take a second argument like the name of the template, the file to render, either header or footer, and then optionally, if I want to pass in some key value pairs like I do for the title, but for the header but not for the footer, I can do that. And so now if I go into helpers.php, it's a little more complex, and I'll wave my hands at the details, but it's just one function. So that's a step toward a better design. We can take this one step further. If I go into my fourth version of this, notice now that I'm doing something even more kind of cryptic, and I know this is a lot to absorb at once, but we're just kind of cleaning things up. Now I'm putting my helpers.php file into a folder called includes, just an arbitrary name where I want to put stuff that I want to include, and then the rest of this is the same. But if I look now in gedit, notice that I've gotten rid of all of those other files, and I've moved them, for instance, into here. And then in templates, I have this here too. And so this is all now toward a step of using a much better design pattern, and we're very quickly going to move away from PHP's default functionality, which we started here with, where you just commingle PHP and your HTML and your CSS, and you just spit it out and you go about your way. It's not going to be very maintainable. Just like in C, we started using multiple files and multiple functions and factoring things out. We'll do the same here, and in fact, in the fifth and final version here, I did one other thing. You can even use ... which again is just the parent directory, to be even more security conscious. Because if I look at the listing here for fifth and final version, notice that I have one directory here called public, and then on the same level, so to speak, I've got includes and templates and then that text file readme. And the reason I've structured it like this, and so many web hosts, especially those like $5 a month ones or $10 a month ones if you've ever had one of these services, what so many of them do is they just expect you to dump all of your files into one directory, like we did already with this very first example. But as soon as you start building more sophisticated sites that start to store data you care about and files you care about, actually organizing things correctly and with more security consciousness in mind, can we start to defend against all of the friends that you have either in or outside of this class who, as soon as you start making programs yourself on the web, are going to start picking on you and on them. And so we'll look ultimately at this design. This is just a picture that depicts the following. We're going to put all of our programming logic in one or more files, and we're going to just start calling those controllers. It's where the brains of our websites actually are. Then we're going to have views, and views are as simple as just separate files called templates often that just have the aesthetics of my page, what I want the page to look like, the colors and the layout and the positions of all of the variables. And then more interesting that we'll eventually get to is the model, which is going to be just the word we slap on other technologies that we bring into the picture, like actual databases, so that when you want to save information, you don't just send an email to your proctor or to yourself, you actually store it in a database using another language known as SQL. And so we'll leave here today and pick up with this on Wednesday and introduce databases then.